Hey guys, so today we're going to finally start actually performing dilations. I know we've been talking about dilations, right? Specifically, we were finding, hey, find the scale factor, find the scale factor, find the scale factor, right? How much was the image expanded by or shrunken by, right? So today you guys are actually going to take that scale factor and perform that dilation yourself, right? So that is going to be our goal with this video, right? So the idea um, is that there are two types of dilations that we can think about, and I'll get a little bit more detail here in a second. But again, you guys will be performing, the dilations given a specific scale factor. That is going to be our objective. Now, again, before we jump into it, let's just recall what we did last week. Last week we were talking about, hey, find the scale factor, right? So find out by how much the image expanded or how much did it shrink by. The little formula that we talked about for scale factor, okay, scale factor, I'll abbreviate SF, is just a relationship, right? It's a ratio, it's a comparison between the new over the old. So kind of the hardest part here is just making sure that you understand, hey, which one is the old one, which one is the new one? Well, it says find the scale factor for pre-image A. So pre-image, that's the before, and then the after would be our image B here. All right, so if I go over here and take a look at what I have two triangles. And I know it's kind of hard to see, but this is B over here. So this little triangle, that is the image, right? That is the image, that is the image. So that is the new one. That is the new one, that is the new one. I'll go over here and highlight then A right here, this much, much bigger triangle. That is our old one. So again, just talking about, just by looking at it, we can talk about it and say, hey, going from the old one to the new one, going from my pre-image to my image from A to B, it is shrinking. So my scale factor has to be a number between 0 and 1, right? If we're shrinking it, we have to have a scale factor that is between 0 and 1, something like 1/2, right? We're cutting our pre-image in half, or 1/3, where we're shrinking it down by 1/3 of its size. 1/4, we're shrinking it by 1/4 of its size. Well, let's go and actually calculate the scale factor. So for scale factor, I'm going to compare a side on the new one. So on the new one over here on the green one, I'm going to pick the left side of that triangle. So I count the spaces. Okay, that's just 2 units. All right, so I'm going to put 2 units up above, and I compare it to the same side of the old pre-image. So again, if I was talking about the left side of this right triangle, I'm also going to compare it to the left side of the old one. So let me start counting. 1, 2, 3, 4, 5, 6, 7, 8, 10. That was a distance of 10 units. So there's our scale factor. Our scale factor is 2 over 10. Of course, we do want to do better than that. We want to simplify our fractions whenever we can. 2 over 10, we can simplify by 2. So my scale factor, what is 2 divided by 2? That's 1. What's 10 divided by 2? That is 5. So take a look. And it made sense, right? We were looking for a scale factor that was between 0 and 1 because it shrunk 1/5. That means that blue one, that old triangle, right? It got dilated. It got shrunken down by a scale factor of 1 over 5. It got shrunken by 1/5 of its size. So again, that's pretty significant. You can see there that the triangle pretty much shrunk to almost its smallest it could be on this coordinate plane. So our job today, guys, is going to be, I will give you the old pre-image, and I will also give you guys the scale factor, right? So I'll give you like the blue triangle here, and I'll say, hey, your scale factor is 1/5. Your job is now going to be to give me the new image to actually perform a dilation. So let's talk about it. Perform. Example number 1 says perform a dilation from the origin on a triangle OMG. So that's triangle OMG using a scale factor of 2. Now this is very, very important. So again, we are performing a dilation. We're either going to expand or we're going to shrink it. And let's actually talk about that. Our scale factor is 2, right? It's a number greater than 1. So that means that this triangle OMG is going to start to expand. We should see it double in size by a scale factor of 2. But here's a very important thing to understand. We're dilating it where? From the origin. So what does that really mean? You can think of it, this right here is going to be the center of our dilation, right? And so when you're dilating from the center, what we call the origin, which is located at 0, 0, right? That's the origin right there. So again, when you're dilating from the origin, your image is expanding away. So take a look at, if I can draw arrows to all three angles here. So that's what it used to be, right? All that distance is now going to expand away from that center. We're dilating away, away, away from that center. Whenever you have a scale factor a greater than 1, like for example here 2, imagine like there was an explosion at the middle of your graph. And again, all of these points are just stretching out. They're exploding away from the center. What if our scale factor was something like 1/2, right? What if it was a scale factor that shrink it like 1/4, 1/5? Then you want to think of your origin, right? That center almost like a black hole. It's starting to pull everything towards that center, towards 0, 0, 0, and we should see that triangle shrink. So that's actually going to be example number 2. But right now, all right, the idea is that, hey, the center, our origin, that's where we're dilating from, and because it's a scale factor of 2, everything's going to start blowing up away, away from that center. Now, how do we actually perform then the dilation? What do we actually have to do? Well, when it's from the center, when it's from the origin, it's actually pretty easy. We're going to take all of these coordinates and we're going to apply a scale factor of 2, all right, which means we're just basically going to multiply all of these coordinates by 2. So I'm going to write all of my coordinates here: coordinate O, coordinate M, and then coordinate G. I'm going to give the name of all those. So O here is sitting at -4, 1. M is over there at 3, 2. And then G is down here at 2, -2. Now again, you can only do this when you are dilating from where? From the origin. You basically, all you have to do is you take the coordinates, right? You find all your coordinates, and then you're going to multiply by your scale factor, whatever your scale factor is. And again, that's only you can only do that when it's dilating from the origin. I'm going to show you guys a different dilation that doesn't happen from the origin. But in this case, we're going to now apply our scale factor. All of these coordinates are going to change by a scale factor of 2. We're going to double all of them. We're going to multiply every single thing in here by 2, by 2, by 2. We're multiplying our x's and y's, everything by 2. So let me go ahead and change colors here so we can tell them apart. I'll go ahead and use, well, that's already, green's already taken. I'll use this orange color. So if that's O, right, if O used to be -4, 1, O prime, right, now the image, right, that's the pre-image, this is now the image. What are the new coordinates for O prime? Well, when we apply our scale factor of 2, when we multiply it by 2, -4 times 2 is -8. 2 times 1, that's just 2. And we're going to apply that to every single thing on here, right? And apply it to the coordinate for M. 3 times 2 is 6. So M prime is going to be 6, what's 2 times 2? 4. And then lastly, we're going to apply it to G. So G prime is going to be, the new coordinates should be 2 times 2 is 4. 2 times -2 is going to give me -4. So there we have it. Those are all the new coordinates. I just got to make sure that I plot them correctly. All right, so we're going to go over here to my graph. We're actually going to perform the dilation. I'll go ahead and use blue. So I'll start here with O, -8, 2. So I go left 8, up 2. That is going to be my new, don't forget to label that. That is my new O prime. What about M prime? 6, 4. So 6 to the right and up 4. That is going to be M prime. Don't forget to label. And then lastly, G prime. 4 to the right and -4 down. That right there is going to be our G prime. Okay, obviously don't forget to connect. See if I can connect my triangle as straight as possible, right? This might be a little bit challenging on our Chromebooks, but we got it. So there we have it. That is how you perform a dilation when you're dilating from the origin, when you're dilating from the center of your graph. I cannot stress that enough. Okay, when you are dilating from the origin, from the center of your graph, you basically just take all of the pre-image coordinates, right? So all those nice corners of my triangle, right? I take all those coordinates and I apply the scale factor. I multiply by my scale factor to get the new O prime, M prime, G prime. And then all you have to do is just go back and graph it. But take a look, right? Remember, I told you when it's happening, when the dilation's happening from the center, you can think of everything kind of exploding out away from it. Imagine somebody placed some TNT, some dynamite at the center, and it just basically blew up our triangle away from that center, right? We can kind of see it expand from the origin. All right, let's try that one more time. So again, think of that like an explosion. Now take a look at this one. Example number 2, perform a dilation. So again, from the origin, I can't stress that enough. So when it's from the origin, from 0, 0, when we're expanding from the center of our graph, we can use the coordinates. We can go ahead and use the coordinates. And it says, so perform a dilation from the origin on the figure. And then those should not have been prime. MASH, it's just MASH using a scale factor of 1/3. So ignore those. My apologies. I don't know where those primes came from. Right, the H didn't have it. So again, it'll just be our regular pre-image MASH. This time though, we are going to apply a scale factor of 1/3. Right, and when you have a scale factor, something that is between 0 and 1, remember that's shrinking it. That is going to shrink my image here, my image MASH. So this time you want to think of like that center, that origin, as almost like a black hole. It wants to suck everything towards it. So again, A, you're going to see it start coming closer to that origin. S is also going to get shrunk towards it. Same thing with H and same thing with M. Everything is getting pulled in towards that center by a scale factor of 1/3. So how do we do that? Well, first let's go find our pre-image coordinates. So MASH. Let's go through that. So let me find a different color here. I'm going to need a little space. So I'm actually going to spread this out a little bit more because I do have to multiply. MAS, and then H. Okay, so let me get the coordinates for M. M as sitting at -9, 3. So M right here, it is at -9, 3. All right, what about A? A is over here at 3, 3. S is over here down here at, what is that, 6, -6? Whoops, 6, -6, not -6, excuse me. 6, -6, 6 to the right, -6 down. And then lastly, H. H is -6. I think I gotta hit myself right. -6 to the left, and then -6 down. So those were our original coordinates, our pre-image coordinates, right? And again, when you are dilating from the origin, you're basically going to take all those coordinates and apply your scale factor. You're going to multiply by a scale factor. This time we're going to multiply by a scale factor of 1/3. We're still going to go through and multiply, but we're multiplying by a fraction here, times 1/3, times 1/3, times 1/3, times 1/3. Everything is getting multiplied. The x's and y's here are all getting multiplied by 1/3, right? So this might be the tedious part, but if we know kind of shortcuts, if we can start seeing patterns, you're actually going to realize this is actually pretty quick. So let's give the new coordinates here. What would M prime now be, right? What would M prime now be? Well, let's take the first one. I'm going to need a little space up here where I'll show my work for the first couple. It's saying -9. That x coordinate -9 times 1/3. And if this is the part that's confusing, you got to go back. To our elementary school days when we were multiplying fractions. How do you multiply -9 times 1/3? Well, that's -9/1. You multiply across your numerator, across your denominator. So -9 times 1 is still -9. 1 times 3 is 3. -9 divided by 3 is -3. So that x value right there is going to be -3. All right, let's do that one more time with the y. The y, original y was 3. We're going to multiply it by 1/3, right? That's 3/1. Multiply across your numerator, multiply across your denominator. 3 times 3, sorry, 3 times 1 is 3. 1 times 3 is also 3. Whoa, go back. So 3 divided by 3 is going to give us 1. So that is our new M prime coordinate, -3, 1. And here's the thing, guys, when you multiply something by something like 1/3, what are you really doing? What were you really doing? you're basically just dividing by 3, right? If you multiply it like by 1/2, right? If you're ever multiplying by 1/2, you're really just dividing by 2. If you're ever multiplying by 1/3, you're basically dividing by 3. If you multiply by 1/4, guess what? You're dividing by 4. So that's what I mean that, hey, these go pretty quick if you see those patterns and if you can notice that. If not, go through and show your work. It might just take you a couple extra minutes, but it's okay. It's okay. Let's find A prime. So right here, I'm like, hey, that's 3 times 1/3. I could go through and show my work, but I know that when I multiply by something like 1/3, I'm really just dividing by 3. So 3 divided by 3 here is going to give me 1. Same thing for the y's. 3 times 1/3. I could go through and multiply that if I really wanted to, but it's just going to give me 1. Right? It's just going to go through and give me 1. It's the same thing as dividing by 3. Right? If I had 1/4 or 1/2, I'd be dividing by by 4. I'd be dividing by 2. Let's go through S. S prime. Same thing with this one. I have 6 times 1/3. I could go and multiply that, but again, 6 times 1/3 is the same as dividing by 3. So 6 divided by 3 is 2. Same thing here, except in this case, it's -6 divided by 3, which is -2. All right. And then we got the last one here for H prime. -6 divided by 3, or just -6 times 1/3, is going to give us -2. And same thing for that Y, -2, -2. If you need to do that little side work, right, if you need to multiply and show this work, you're more than welcome to, guys. It's just going to take you 30 seconds longer, really. So again, don't let that stop you from completing these problems. All right, so let's go through and actually graph it. This should be my new image here. I just got to go through and actually graph it, and I should see it somewhere inside, right? Because my scale factor is 1/3. It's shrinking. It's pulling everything towards the center. So let me plot the first one. M prime is -3 to the left, 1 up. Label that M prime. All right. I'm going to get rid of the the point right there in the middle of the origin so it doesn't get confusing. A prime, it's 1 to the right, 1 up. S prime, it's 2 to the right, -2 down. And then H prime, -2 to the left and -2 down. Whoops, and I completely forgot to label it. That was A prime, that was S prime, and then that was H prime. If I just go ahead and connect them, that is my new image. That is how you perform a dilation where your scale factor is something like 1/3, where it's shrinking it. And you kind of see, right? It was pulling towards the center, towards the center, towards the center. All right, so that is a dilation, guys, from the origin. So again, both of these examples, example number 1 and example number 2. Okay, the important part that you need to understand is where's that dilation happening? Well, in this case, it's happening from the origin. So again, it's either pulling everything towards the middle or pushing everything away from the middle, right? Think of it as an explosion or a black hole. All right, so those were dilations from the origin. What's the other type of dilation? Okay. Oh, and sorry, one last thing. When you're dilating from the origin, again, all you need is take the pre-image, take those coordinates, and multiply by your scale factor. So what happens when the center of the dilation isn't the origin? Take a look at example number 3 and example number 4. It says dilate the triangle using a scale factor of 1/2. So I know this is going to shrink. I know this triangle is going to shrink, but where is the center of my dilation? It says U as the center. So it says dilate the triangle using a scale factor of 1/2 and U as the center. So what you want to think of is that as like your anchor point. If you go to your desktop and if you click on your desktop and then you create that little kind of highlighting, right? When you can highlight and you can create this little square, this kind of broken up square, and you kind of drag it across your desktop. That's basically what is happening here. Because U is my center, I'm either going to push things away, right? I'm either going to expand it away from you, or we're either going to pull towards you, right? So everything would be coming, I should actually start from here. Everything would be coming closer to you. All right. So how do we perform a dilation when the center is not the origin? Well, this time it's a little bit different. This time you're actually going to have to use the sides. You actually have to count the sides. You cannot use the coordinates. So what I mean by that, so here is U, that's the center. So from U to W, how many units was that? That was 1, 2, 3, 4. So that was originally 4 units. We're going to shrink that by a scale factor of 1/2. Same thing from U to V. U to V used to be 2 units. We're actually going to take those lengths and we're going to start, we're going to apply our scale factor and we're going to start to shrink our triangle. You're going to see that here in a second. So let me start down there with 4. So I said that, hey, the bottom of my triangle used to measure 4. So we're going to take our 4 and we're going to apply our scale factor. We're going to take that distance and apply our scale factor. So what's 4 times 1/2? Right? If you know how to divide by 2 here, you should be quick. I'll actually show my work. That's 4 over 1. 4 times 1 is 4. 1 times 2 is 2. 4 divided by 2 is 2. So take a look, take a look. That is the new distance. This used to be 4 units. From U all the way to W, that used to be 4 units. When you apply your scale factor, you're only going to go as far as 2. That is where the new W prime should be. So see how it used to be 4 units and we kind of pulled it back, right? We pulled it back by half because we're applying a scale factor of 1 over 2. Same thing is going to happen to this side. So from U to V, from U to V. Okay, if I can find my eraser. All right, so from U to V, that used to be a distance of 2. Well, let's apply our scale factor, 1/2. So that's 2 over 1. 2 times 1 is 2. 1 times 2 is 2. 2 divided by 2 is now 1. So that new distance right there, this used to measure 2 units. It's now only going to measure 1. Instead of going up 2 spaces, okay, that distance is getting shrunk down to a distance of just 1. That is going to be your new V prime, right? And we actually have our triangle. We actually have our triangle. If I erase a couple of things here, okay, that U is also going to be U prime. You already have your triangle. That's U prime, that's V prime, and that's W prime. This right here is your new triangle, right? See how it lives inside of the original triangle, VUW? So we just applied a dilation, and again, the center was U. So here, everything was getting pulled towards U because our scale factor is 1 over 2. It's getting shrunken towards U. So when your center is not the origin, do not use the coordinates. Use the actual side lengths. Let's try that one more time. Example number 4. Dilate the triangle using a scale factor of 2. So this image should expand. It should expand, and G is the center. All right, so let me highlight that. G as the center. So this is G. That one's not going to move. G is going to turn into G prime, and everything, though, is going to expand. So this distance is going to expand by a scale factor of 2. This distance is going to expand by a scale factor of 2. All the other distances, again, are being stretched out by a scale factor of 2. So let's take it one side at a time. So what should the distance from G to F be? So, sorry, from G, it used to be 1, 2, 3, 4 units. Well, let's apply our scale factor of 2 to that. Well, what's 4 times 2? That is going to be 8. So that distance that used to be 4 should now be a distance of 8. 1, 2, 3, 4, 5, 6, 7, 8. All right, so right there at the very edge, at the very corner, that's actually going to be my new F prime. That's actually going to be my new F prime. All right, let's do that same thing with G all the way down here to H. G to H used to be 1, 2, 3. Well, let's apply a scale factor. So it used to be 3. Let's apply a scale factor of 2. What's 3 times 2? That gives you 6. So that distance that used to be 3, right, it's now being expanded. It's being dilated by a scale factor of 2. So it makes sense that it went from being just 1, 2, 3 all the way to 4, 5, 6. This is where the new H prime is going to be. All right. Whoops. And let me actually erase those bunny hops. All right, we got one last side here, one last side. From H to E. So from H to E used to be 1, 2, 3, 4, 5. Okay, so it used to be 5. We're going to now apply a scale factor of 2. Well, what's 5 times 2? That gives us 10. All right, but now we're actually going to be way down here, way down here, way down here. Right, so we're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We're going to be a little bit out of our graph over here. Okay, so notice how that length went from 5 and it doubled by a scale factor of 2, so it is now 10. Well, if you put all of this together, this is E prime, by the way. Let me go ahead and connect all of that. So there we have it, there we have it, there we have it. That's how you perform a dilation when the center, the origin, is not the center, right? So notice this used to be 1, 2, 3 units. When you apply that scale factor, G is the anchor, right? That one does not move. It now turned into 1, 2, 3, 4, 5, 6. It doubled in size. This top side here that used to be 1, 2, 3, 4 units, again, it doubled in size to be 4, 5, 6, 7, 8 units long. Okay, but again, it's all happening from point G because that is your center. All right, so be careful with the two types of dilations, right? If it's from the origin, use the coordinates. If it's not from the origin, if it's from a point on the actual shape, use the side lengths, right? And multiply those side lengths by your scale factor.